the value. Okay, Leshik, what did you get? -8. Anyone disagree with that? So then let's see, if it is true, then it should make the statement true. And we're saying that these are equal. So on the left side, 40 minus 8 is what? And then on the right side, if I plug in a -8 for the n, is 40 plus -8 also 32. So that is true. That is the answer for the first one. Did anyone solve it maybe in a different way than the way that I did it? Okay, so then you probably did the 32 in your head, like the 40 minus 8. Oh, okay.
So equation 40 minus 8, I think it's called inverse operation. I subtract 40 from both sides, and then it's left with -8%.
Okay, gotcha. So that is another way that you could have done it, which then ends up canceling both 40s on each side, and then you just get -8 equals n. I was thinking more so like our one-step equations, which ordinarily we combine that already, and then you'd see that you can cancel the 40 by subtracting it, and then you get 32 minus 40, which is also -8. So lots of ways. Some of it might require a little bit of scratch work, but that's why this was like more of a one step you can probably do in your head too. So questions on that? Okay, then here's the next one. Hopefully, if you weren't someone who had their thumb up earlier, that you're seeing some of the different strategies and applying it to this next one. So 25 plus -100 equals 25 minus n. Put your thumb up when you think you know what n has to be. Leave it up. All right, Devon, what'd you get? N equals -100. Okay. So if I plug that in to the right side, 25 minus a -100, does that give me the same thing on the left side? So first, what is 25 plus -100? -75 on the left. If I were to have it like this, what happens with this double negative? And then the right side ends up becoming 125. So how can I adjust it to where it's giving me a negative? N equaling 100. So taking away the negative sign, 25 minus 100 is also -75. Make sense? Okay. So yeah, the value of n is 100. The fact that we're subtracting it comes from the given equation. All right, next one, 3 minus 1/2 equals 3 plus n. Put your thumb up when you think you know what n is for that one. for those down. Okay, so Isabella, is that a thumb up? What do you think, Annie's? 1/2. Okay, so on the left side, if we simplify it, what's 3 minus 1/2? 2.5. I'm gonna put 2.5 and 2.5, same thing. And then if I do 3 plus 1/2, what's 3 plus 1/2? So not equal, how can I adjust this answer? Make it negative. 3 plus a negative 1/2 will give me 2.5. If I plug in a negative. So adding a negative is the same as subtracting. Do we normally write the 3 plus a negative 1/2? No, we probably simplify it to what's on the left. But it will give you the same thing. So it should be negative 1/2 for that. 4.5. Okay, last one. 72 minus n equals 72 plus 6. Put your thumb up when you think you know. Okay, Philip, what'd you get? Sorry, one more time. Okay. So if n is -6 and I plug it into the left side, what happens with this double negative? Becomes a positive, which we saw in one of the earlier examples. We were plugging in a wrong answer. So yeah, it is a rule. A double negative, it makes it a positive. Or you could think of any subtraction problem as adding the opposite. So I don't know. 8 minus 5, I'm sure you know, is 3. But that's the same as doing 8 plus a negative 5. So adding the opposite gives you the same answer. Same when you have, for example, this 72 minus a negative 6. If you add the opposite, it gives you the same thing. Okay, so all subtraction is adding the opposite. So this is the answer for the last one. Questions on that? Okay, so good integer rules to know, but remember your calculator could always solve that part for you. It might not be able to multiply the variables for you, but the numbers it can do. All right, remember combine means add. Sometimes we're adding a negative, and that's the same thing as subtracting. So let me briefly read you the goal of today, and that is to write quadratic expressions in different forms. Very similar to what we did yesterday, except for yesterday we really focused on diagrams. Today we'll let you decide what method you like better. Not only that, we're adding negative numbers into the mix, so that's what that warm-up was kind of priming me for. Saying that, yes, you can rewrite it as this, and it's still the same thing. And also, we're adding some vocabulary today. You need to know the difference between factored form and standard form by the end of the lesson. I'm recording right now, just like I always do, so make sure we're keeping up. Puzzle piece of lesson 9. And you can expect a quiz tomorrow over what we're covering so far, except for the first 2 lessons, because we already had a quiz on those 2 lessons. We're really almost done with the units. There's only 17 lessons total. Some of them are going to be combo lessons, so we're really almost done. Make sure that you're keeping up with your assignments, all of that stuff. Any questions? Remember what I said, there's only 3 unit tests this semester. So each of them have to be good. Time is running out to retake or correct that unit 5. Mind you, we already did that once in class, so if you're still wanting to improve that grade even after that, you have to make it a priority to come to tutoring, come to Saturday Academy. If you're failing, it's probably because of the unit 5 test score. So if you're not doing anything about your grade, like, I don't know how to help you. I really don't. Summer school is not going to be free anymore. So your options are your parents pay for summer school, or you take it again as another class. So make sure you're doing everything you can now. If you're failing, you should expect a Saturday Academy invite. I've already sent emails out about that. Questions? Yeah. So then moving forward. So yesterday we used diagrams to expand expressions such as x times the sum of x and 5. What property do we apply when we expand them? The distributive property. So if you already know how to apply the distributive property, great. You don't necessarily have to change your thinking at all, but a diagram is a way to help you with that. Yes. So in our diagrams, we were kind of using the fact that if you have like dimensions, you multiply them to get the area. So I could write the x times x plus 5 using a diagram. Here's one of my factors. Here's what's in the parentheses. And when I multiply them, I get x squared and a positive 5x. Note that this is the simplest it can go. I don't have any like terms here, because like terms would be the same exact variable to the same exact exponent. What's the exponent on this x? A 2. What's the exponent on this x? So they're not like terms. That's what I mean by that. Now today, what's different from yesterday is we're gonna now have negative numbers in the mix. So if I change the expression to x times x minus 5 in parentheses, here's what the diagram might look like. So you always keep the sign that's in front of each term. So like these two are both positive. If the sign's not written, it's assumed to be positive. This is negative, so I'm showing that in my diagram. And when I have a positive times a negative, what do I get? A negative. That's why x times negative 5 is negative 5x. The combining, so combine means add, is still the same. Oops, let me rewrite that. So x squared plus negative 5x, although it's kind of redundant to write plus negative 5x. Usually we just shorten it to this, although we do mean the same. Because if I want to say like the area of the whole thing, I have to combine these. Or if you can apply the distributive property, you can do that way too. The question on the diagram. Remember that your calculator could do 1 times negative 5 to do the numbers. It can't do the variable part. You have to know that x times negative 5 is negative 5x, that x times x is x squared, and so forth. So you can use the diagrams, or you could use one of the other methods I talked about. Do you guys remember what those methods are? And well, the diagram. And then there's one more. You remember how I referred to it as? Double distributing. So I'll leave that up to you. I will say that when we go over this one, I'll show you a diagram. just so we could practice at least if it's a 2-term times a 2-term, how the diagram looks. But at the end of the day, if you did foiling, if you did double distributing, if you did the diagram, you should get the same answer no matter what, unless you're making some error. So try number 1, show that these two expressions are equivalent. And then if you're feeling confident, move on to number 2. You'll write their equivalent expression. That'll give you 2 minutes. Okay, so even if you did a different method, I'm still going to demonstrate the box method at least one more time, because that tends to help more of you visual learners, more of you right brain, creative minded people. So this only works really if it's a 2-term times a 2-term. So if I'm setting up using the box method, the same parentheses, if you will have to be like on the same side. So like I would have an X here and a -1 here. Always keep the sign that's in front of the term. Then the other parentheses happens to be the same. X and -1 is how you set it up. So then table 2, what's X times X? Table 3, what's X times -1? So the dimensions of this box are -1 and X. We're multiplying them together with -1 times X. Close. A positive times a negative gives me a no. Okay. So if you have an odd number of negative signs when you're multiplying, so like here I did a positive times a negative, I have 1 negative sign. So your answer should be negative. If you have an even number of negative signs, like for example, a -1 times a -1, there's 2 negatives there. Table 4, what's -1 times -1? So a negative times a negative gives you a positive. Positive times a negative gives you a negative. So then here happens to be the same dimensions. -1 times X is -1X. Questions on that process? Now, when you write your answer, because the area of this entire rectangle would be all of these smaller areas added together. You can only combine terms if they are alike. So does the X squared have a like term? So that's going to be this X squared in my answer. Does the -1X have a like term? And it happens to be exactly the same, but they're like terms because they're both X to the first power. -1X plus -1X is what? -2X. So combine means add. -1X plus -1X is -2X. And then the positive one doesn't have a like term, but it's still in the answer. And that proves, it said that it would be equivalent to this. This proves it. Again, you could have done any of the other methods, but your final answer would have to be this for it to be true. Okay. Now, for the next part, I told you to get started on it as soon as you finish this one. So maybe some of you already did. I'll give you 2 more minutes to try as much of it as you can. And you can use the box method again. You can use foiling, you can use double distributing. I'll make sure to go over an example of each of those today. Tomorrow you'll have more practice multiplying binomials together like these. But for right now, whatever you want to try. If you take out your notes from yesterday, you need a reference. Hey, I mentioned I do at least a FOIL example and a double distributing. Which one do you want to see first? I'm telling you, they're exactly the same, aside from like the little pictures that I draw. So foiling or double distributing. Okay. So double distributing would be me taking the first term from the first parentheses, multiplying it by both the terms in the second parentheses. So what's x times x? X times -1. Table 2, can you tell me? X times -1. Good. So that's my first distributing. I distributed once. Double distributing, you have to distribute that other term that you haven't done anything. So then table 3, what's 1 times x? And it's positive, so I'm going to show that with a plus here. And table 4, 1 times -1. Good. Notice I distributed the positive 1 to these other numbers. Questions on that? And then usually you will have to combine like terms after that. And typically it's going to be your x terms. I don't want to say all the time it will be, but usually your x terms. Table 5, what's -1x plus 1x? You can use 1x. Anyone else at that table? Otherwise? Well, what's -1 plus 1? Which ends up being 0 times x, which is just 0. So really that middle term ends up canceling because of that reason. -1x plus 1x is 0. And then that -1 doesn't have a like term. It's still in the answer. Just as -1. So this is what it'll look like if your middle term cancels, with which can happen. Good on that? Okay, and whatever method you did, you're literally doing the same multiplication, the same combining like terms. It's just a way to organize. So since we did double distributing on that one, I'll show you foiling again on this next one. But no, that really is up to you what you do. So x minus 2 times x plus 3. Table 6. If I am foiling, what do I multiply first? Or can you tell me what FOIL stands for? You will multiply the x's first because those are my first term in each parenthesis. So FOIL stands for first, outer, inner, last. So multiplying the first terms, class with x times x. And then following this order, the outer terms are what will multiply next. That would be this x and this 3. Table 1, what's x times 3? (3x), and it's positive, so I'll put plus 3x. Now we have our inner terms that we need to multiply. So -2 times x, that's my inner terms, my inner terms of the problem. Table 2, what's -2 times x? Okay. And then table 3, we're multiplying now our last term in each parentheses. So that's -2 times 3. What does that give me? -2 times 3. But while they figure that out, does everyone understand what we mean by first, outer, inner, last? Like that's the order. That's the same order when we double distribute, by the way. What is -2 times 3? Okay. Is my answer fully simplified? What's something that can be improved? I could combine my like terms, which are these x terms. What's 3x plus negative 2x? A positive 1x, and I'm going to show that by putting a plus. I'm going to bring down the x squared and then negative 6. Questions on that? For 2C, I'll let you try whatever method you want. However, I want to make sure that you don't make this common mistake. So in 2C, it looks like this. Am I able to just distribute the exponent? You cannot. If you tried that already, don't do that. The answer is not x squared plus 4. What you have to do is first remember what exponents tell you to do. What do exponents tell us to do? Like, what does 3 squared tell us to do? To multiply what? So verbalize it. What do exponents tell us to do? Multiply the base by itself, however many times it says. So really, x minus 2 squared should be written as x minus 2 times x minus 2. And then you could do whatever method you want. I would encourage you to try foiling or double distributing, because I think you've done a lot of the box method already, but I'll leave it up to you. Solve this one now. I'll freeze it, I'll solve it too. But you practice as well.
Oh, I didn't realize I was recording this whole time.
It's like our fourth example of a binomial times a binomial, a 2-term times a 2-term. I'll show you the answer. No matter what method you chose, you probably still even did the multiplying in the same order. Okay? If you did foiling, x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is also negative 2x. And negative 2 times negative 2 is a positive 4. Combine my terms. And that's my answer. Questions on that? If the multiplying is still a struggle, don't worry. I've added in an additional practice tomorrow that you'll do in class, and it should help. And it's a coloring activity, so if you wanna bring colors for tomorrow, I could give you some extra credit if you do get to that part and color it accordingly. But just know, like, if you ever look at the notes in Schoology, I do have some like pictures of both additional methods I showed you today. So here's my double distributing. You wanna take a look at that? It'll be in Schoology, it already is actually. Here's my foiling. First, outer, inner, last. I really like this method, but I know some students have trouble figuring out what their first terms are, what their outer terms are, what their inner terms are. So just whatever method you like best, stick to it. And then that's all we have for the multiplying part. Now we need to meet our last learning target, which is standard versus factor form. Any questions before we do that? Okay, so this is almost kind of like a notice and wonder. It's on the back of your paper. We have this quadratic expression written in standard form. Sorry. So we have this expression written in standard form, and then we have a list of other quadratic expressions written in standard form on the left. We have some other examples on the right that are not written in standard form. So compare them, make some observations with your teammates at your group. Write down, I'd say, at least 3 characteristics of expressions that are in standard form. Then take a look at number 2 once you've done that. Not all of these are considered factored form, but 2 of them on the list, I'll highlight them in number 2, are considered factored form. Think about what these have in common and why you think they're called factored form. That I'll give you a formal definition of later, but have a few observations ready for each. Questions on what you're doing? Okay, so in your groups, give me some observations about things that are in standard form and things that are considered factored form. Table 5. What are some characteristics of expressions in the standard form? Give me one of the ones you came up with. Okay, no parentheses is what she said. Miss Medina. No, she is now in the 7,000 building. Okay, no problem, bye. Okay, anyway, yeah, number 1 is no parentheses for the standard form, which is true. You don't see any of them with parentheses. So that is a characteristic of it. Table 6, what's another characteristic of the standard form? Oh, we can have fractions. You can have fractions. I would say that the ones not in standard form can't have fractions either. Like I wouldn't, that's a good observation, but I wouldn't make that a generalization based off what I know. So I wouldn't add that, even though that is something you could have noticed. Table 1, what's a characteristic of the standard form?
So, yeah, no multiplication to numbers that become
Okay. So no multiplication can be done, or in other words, it's already multiplied.
Yeah.
And then I think what you were also trying to say is that there's no like terms in standard form. They're already combined, they're already in the simplest form. Does anyone else have a generalization about the standard form that we noticed that we can add? Okay, then what about these items that they pointed out are factor form? They didn't say that these are all factor form, but these two definitely are. Table 2, why do you think that they're called factor form? Or what's an observation about them? What's an observation? Factor form. So there are parentheses in this one. Table 3, can you elaborate on that? If there are parentheses, what can I do in both of those examples? You can distribute. So you can distribute, which if you know how to distribute, you know that means you can multiply them. And if you remember from the last unit, factors are things that we can multiply. So like, what are the factors of 12? 3 and 4 are factors of 12. 2 and 6 are factors of 12. Things that you multiply. Okay, so these factored forms look like everything that we've been working on the past 2 days. These look like our given problems. And when we distributed them, we got the standard form. You notice that? How the answers to all the ones on the front kind of look something like this versus these that are like the given problems. So a big skill in Unit 6 is being able to go from factored form to standard form, and that's by multiplying them, by distributing them. In Unit 7, I'm sure you'll be so excited. You'll go from the standard form to the factored form, but we're not there yet. All you have to do in this unit is be able to distribute. Or double distribute, whatever the case is. So questions on that? All right, so you have on your paper like a little glossary. I'll give you a formal definition of each now. Standard form is written down first, so make sure you write like each definition accordingly. Although mine are flipped. So for the standard form, since it's on your paper first, I'll tell you it first. That for quadratic expressions will be written in the form ax squared plus bx plus c. Where a, b, and c are all numbers or constants. And a cannot be 0. So the b could be 0, the c could be 0. We saw some examples of that. But the a can't be 0 because then it's no longer a quadratic expression. Remember, the x squared is what made it quadratic. That's my standard form. My factored form, we have a long definition up here, but they're written as factors. They're things that can be multiplied. So the factored form can be multiplied. If you want to put it in simple terms, it's written as multiples or written as things you can multiply. Let's summarize it like that. Things you can multiply / distribute. So for example, if I were to distribute this and then FOIL it, I would get something that's quadratic because it'll have an X squared in it. So that other example that was on your paper, the 2x plus 3 times x. When I distribute this x, I do still get a quadratic because of the x squared. But when it's written where you can't really see the x squared that clearly, that would be factored form. Written as things you can multiply / distribute. So questions on that? Do we know the difference between standard and factored form? Sure, in this unit, you're going from factored to standard. Next unit will go from standard to factored. But this one, all you have to do is multiply or two. Make sure you have those definitions down. The practice you could knock out maybe in the last few minutes. It's 6 problems total. So give it your best attempt. Do some so that you have less to do later. Tomorrow will be more practice on how to multiply things up on the factor form.